Just jumping on the doggy.
Like it, let her do her thing.
To me.
Hey, hey.
Hey, hey, you. Hey, you.
Yep. It's a live stream, y'all. Printing out a part today. I'm gonna be showing you overhead um, screenshot of what I'm printing, and also I'm gonna be talking. Feel free to ask questions. Leave comments, give advice, all the above. As I get this other camera up. I don't know why this camera takes so long sometimes. All right, let's see it. That's taking forever. We'll just talk. This is what I'm working on, guys. Get torn down. Wanted to upgrade the servo mounts for the steering. I wanted to get rid of some depth wobble that was going on in the front, especially when I had the suspension fully extended at its top point. I would have a little depth wobble. So what I had to do was I had to lower the servo down so that these arms can be level. So that's what I'm working on today. That's what's printing. This was quite a challenge too. Took me a minute. I was doing some designing yesterday and I was doing some recording, but I started to get tired, and you know what happens when with math when you start getting tired, you start messing the numbers up. So I had a few things that didn't quite work out. And this today when I went back in the program to finish up the CAD work, I noticed some measurements that was off by a long shot, and I was like, "What was I thinking?" But I got it, and here we are in the printing phase, and um, this print is going to take 2 hours, so just kind of vibe and see what's happening. See if I can get some people to conversate in here, get a dialogue going. This is one of my first projects as far as a RC car, so it's kind of new to me, kind of fun to just see how creative I can get with it, having as much room as I have to work around in all of this area here. It's different from what I'm used to being able to work in. I came from a background of building model cars, and space is limited with model cars. You have what's there, everything's already printed. So uh, if you want to change something, you have to get the cut. But in this scenario, we're able to start from scratch and build what we want to build. So for me, it's a matter of what do I want to add in there? What do I want to put in? Um, so one thing I wanted to do was try to center off as many of the heavy parts as I could. So in order to do that, we had to go in and change how the servo is going to sit and mount, and also the receiver. I wanted the receiver to be in the front of the vehicle, so it's going to be sitting up top as well. And then another thing to tackle would be the ESC, which I temporarily mounted off to the side, but I can most definitely see the weight of it as the car is driving. So that'll be another thing to tackle on a different day. And I had played around with the idea of having that in the front as well, but I came to the conclusion that I don't want that much weight to be in the front, considering that um, this is a dancer car right now, but I eventually want it to be a hopper. And so with it being a hopper, you want most of the weight to be towards the rear end of the vehicle. See if I can get the rest of this shot in here. You want most of the rear to be where the weight is, so that when it's hopping, the weight in the back will kind of carry it up. So that's the goal here, is to get everything in the front centered, and then get the weight from the half point of the vehicle shifted backwards, which is another reason why the motor here is facing to the rear instead of facing forward. I just wanted to try something different, and I like how it turned out. I really like how it's coming out. All of these servos, I got these set out to the side, and I'm trying to get some content up too about how this thing works, and what I had to do to you know make it reasonable, make it look realistic, and make it function well. The performance is quite well, considering that uh, it's a one of a kind lowrider with 4-wheel drive. So that's something new to me as well, as far as dealing with hydraulics, and given that functionality of having independent wheel drive. You know, we needed that to happen for RC. So this is kind of one of those vehicles where you'll probably be able to take it off road and cruise it. It's a really fast car, um, crazy fast. I did a couple test runs around the house, and the thing just rips. So I mean, it could be a drifter. It could even be a drifter with being 4-wheel drive and all. And the way that it spins is crazy, super crazy. If you get a moment, please like and share the content so that other people can see what I'm doing here. I kind of want to get as many eyes on this thing as possible that are like-minded, so I can kind of really build something amazing. I mean, I'm building something great here, but it only works if the community is behind you as well. So if I can get the people, to get involved and get to talking about this and get innovative and want to collab and do things to create a product, you know, that's where I'm at with it. I'd like to see this thing hit the shelves one day. I'd like to see this thing hit the shelves. That'd be awesome.
Use the pipe.
One thing, and one of the major hurdles that I had to consider when I was designing this was, would it been four-wheel drive and having such a low front end, and the way that this mount works, it's against the traditional way of how you would normally mount a servo. Um, was that these linkages used to hit the diff box, right? And so I would get full turn on the outside, but I wouldn't get the full turn on the inside. And so I was running into a problem with that. So if you've seen that video of me printing out the new diff box, that was to kind of take that beefiness down and shrink it into a smaller package and make it to where all of these parts could move around freely. Because the differences between this and any other four-wheel drive car is that the suspension articulates like an inch and a half. Okay, so that's an inch and a half worth of play that's just there all the time. It's not like when you hit a ramp and on a regular four-wheel drive, you hit a ramp and then the suspension reacts to it, to the bounce or whatever. But with this car, we're sending it up intentionally, or we're dropping it low intentionally, and it's staying in that position. And so when it's like that, you run into these issues where the mechanics are bumping into each other. And so in order to avoid that, we had to lower that, the servo and all of that, make sure that we get those linkages low enough to where when the suspension is fully extended, then the steering is still good. The toe is still the same high as it is low, and that was like a huge challenge and something I put a lot of work into doing. But I figured it out. Now I do not have a background in engineering. I'm just a welder. I went to school for welding. I took a CAD course, that was dealing behind construction, but I never had like 3D modeling or any of that engineering um, training. So me doing this type of stuff is just it's based on my own knowledge of how mechanics work, and so that's why I like to see if people reach out. Um, I like to encourage people to reach out because I know there's people out there that are, well trained and well versed in engineering, and they can give a greater understanding to how certain things work and how the geometry comes together to make a functional part. But that's the goal here. That's what we're shooting for. See, this thing's printing pretty fast. I didn't think it was gonna print that fast. It said that it was gonna take 2 hours, but we'll see. It'll probably be done within an hour. Since Creality's last update, I have been having a couple issues the the platform telling me one thing as far as the time that it will take for something to print, and then it would print like twice as fast, and it will still be counting as if the part is printing, but in reality, the print will be done, and I'd be working on it already. There's a lot going on in the background. Talking to the viewers of this content.
Watch. No. Watch. Watch. Watch it again. Watch. What on that?
You can hear all the shenanigans going on in the background.
Fire at it.
There we go. Is that better?
Hey! Hurry! Ow! Like what?
I didn't know I was running on the wrong mic.
Yours? Make me bigger! You need it here. Now I'm big. I'm all inside here.
All right, so you're just coming in. What I was talking about was how I was just talking about how tedious the process is of doing the geometry when you're not versed or well versed in mechanics or engineering. And so I'm a hands-on person, and a lot of what I do is just based off of being an artist, being a welder at trade. Um, and having these old hobbies when I was a kid that I'm now revisiting. Um, as part of my therapy, I was dealing with uh, thinking about things that I used to enjoy when I was younger. And this was one of those things that kind of just fell by the wayside, that brought me joy when I was younger. And so to get back to a happy moment of me, because I know, when you're working and you got the whole family life going, sometimes it's easy to forget about yourself. Sometimes it's easy to just be in it for everybody around you and making sure everybody else got it. But when it comes to you and uh, having something that's an outlet for you that can help you to reset or recalibrate yourself, um, it has to be your hobbies. Things that you enjoyed when you were younger. Things that you had time to do and you actually did that with your free time. So creating this car has been that for me. Um, it just helps me to connect back in with my inner child and helps me to reconnect with my inner child and just kind of fill it out, like get back to that place where there was a happy moment in life where there was nowhere to be and nothing to do but just sit and create and and be happy in the creation of what you're doing, be happy in that space. And so this car is that for me. um I've had a lot of time to work on it, and it's been going crazy. I've just started to share last week. I just started to share the progress, and I've been getting so much love. So thank you all for showing me love, with this design and how I'm bringing everything together. Um, Today, what we're working on is, like I said, that servo steering bracket, and just trying to make sure that we get it in the right direction. Make sure that we actually have this thing running straight when it's going and it's ripping. Because I took it for a couple of test drives a few days ago, and the thing is ripping crazy. But uh, there's a difference in the steering if I have the suspension lifted totally up or bottomed out. And so what the goal is here uh is to reach a medium, where when this thing is at ride height, it's at average steering, but it's at the middle point, And then when I have it extended or lowered, we have a slight actuation of the linkage, to where it's not overextending the linkage. And so that was the main goal here. And also to get rid of that bump steer. Because that's what happens when this thing is fully up at the top. The linkage rods are at their max. They're all the way bent out, and then the steering gets a little shaky. But we're fixing that today. We're doing just that. Feel free to comment or leave some questions. I would love to interact with you all. Y'all have any questions about the chassis right now, or parts that you see that you're curious about, fire away. Um, this design here that I came up with was a belt drive. And I went with a belt drive because the gear, when I was dealing with the plastic gearing, I can hear all the cackling and stuff, and it sounded, um, it didn't sound good to me. So rather than dealing with different ratios of gears and stuff like that, I just decided to go with a belt drive. So when I did the belt drive, it took that sound away, but it added a little more space um, to this build than I wanted to take up inside the middle. Um, but I don't have any problems with the drive shaft now. I don't have any unnecessary noise, you know, and it actually sounds cool when it's taken off. It has a nice resonance too. So that's one thing. Uh,
Are you gonna be the white toad?
and these linkage rods, all of this stuff was plastic at one point. Uh, it's just over time, as I finalized like what I wanted this thing to look like, I decided to go in and add a little silver to it, get a little aluminum in there, and um, make it look more professional, make it more sturdy and more durable. When you're dealing with the plastics and just plastics only, you're dealing with a product that's just it's gonna break over time, and there's some inevitable breaks, unfortunately, in RC world, because we all want power, right? We all want to give it more power. We all want to give it more speed. We want to make it lighter, and we do all of this at a cost. We gotta stop the noise. Yeah, so we kind of sacrifice durability for these things sometimes, and that led me to end up with these with the rods and the ties and all that stuff, the linkages, those parts. You kind of have to make those strong if you want the thing to last. And so I want it to last. I want it to last. I want to see other people build this thing, and I want to see how they take it to the next level. But I got to push it to the limit first and see exactly how well it is, and what it will be for other people when they get a hold to the STLs. Um, but I'm still working on it, and I would say I'm about 80% done with prepping all of the STLs for this. So hey, stick around. The STLs are gonna be free. I'm gonna post them for free. They're gonna be on Thinkiverse. Um, so keep an eye out for them, or check in with me on a regular to see when I drop them. I kind of want to just give back to the community and have something that I've created out there. Uh, but that's also cool. How cool will it be to have a crawler with the um, functionality of hydraulics, or just the lowriders? I was a big fan of lowriders, growing up, and so that's what took me into the model car lowriders and making those into hoppers. And here we are, like some 30 years later, um, tapping into the RC world, and so this gives me a new hope, that there's more in life for adults other than just working and providing for a family, but actually doing something fun, staying true to ourselves and doing stuff that we like to do and designing things that we like to design. There's a couple things that I need to put back together here, and I was holding off on that just so that I can, show some things, um, if people had questions about or were curious about how I mounted all this stuff and put this together. So, um, I've become a firm believer of the inserts over time. They have made a great difference in my builds, versus just screwing into the plastic. And because what I noticed is when you're prototyping something, you're gonna take those screws in and out, in and out. Like for example, you can see how ashy this screw looks. You can see all that whiteness inside of that screw, um, versus a screw like this where it's just darker. That's because of how many times I took the screw in and out of the plastic. And so it's like every time you take a screw out of the plastic, you're taking plastic with it. Especially if you're using like a drill or something like that. You're gonna create heat as you're screwing into it, and the part is gonna fray and is gonna end up melting onto the screw. So to rebuttal that, I started to use these inserts where you get your hot iron and you heat press them into the holes, right? And that was the biggest game changer because it makes the screws easier to come out when I need them to come out. And if I want to secure um a screw in, like say for example, I want to secure a screw in, but I don't want to tighten that screw all the way down. I just put a little bit of lock thread on there, and I can set it to the right adjustment. And once the Loctite seals up nicely, it'll stay together, but it'll still have that space for play. And so having those inserts, man, a game changer. So if you aren't using those already, tap into it and use those because those are pretty cool. Um, any suggestions on where I should mount my my ESC, let me know. Right now I'm taking up this whole cab with that bracket that I was printing out. This is going to end up at the top side of that bracket in this area, and then the servo will be off to the right here. So once that's all said and done, we'll have a little space. If I want to put the ESC, I could put it underneath in this area here, or I can bring it down to the back and I can have it down low in the back. And that's probably where I will put it at. Um, but I'm not a big fan of it being off to the side here. Another way I can put it is I can tuck it further underneath the rear servo here. So that I got a few options. My goal here though is just to kind of try to balance that weight out and center that weight, because because it has a fan on it and the little heat sink, it adds some weight, you know. And so if I could have it my way, I want that weight to be towards the back rather than in the front. So I mean, I got enough weight with these two servos being they when they get mounted up here in the front side. And this is what controls the hydraulics for the front. Actually comes together pretty good, and I went through quite a bit of designs to get to this point even, when it comes to how I mounted these servos. The rear servos used to be upright mounted like this, like the front servos. And in order to get my shell to sit down further inside, on top of the chassis, I went ahead and I flattened them out so that they can sit flush, and that back window of my body is gonna sit lower now. So now I have this whole chassis with the body pretty much sitting on the ground now, and it looks really cool. It's it's starting to come together, and it reminds me of a realistic car and how it sits and just how it responds when it hits a bump, like when it's driving, how the suspension responds to those bumps is it's crazy accurate. So there will be some content, you know, coming to where I actually I show this. Another thing that I haven't showed yet, but I will make videos on, is how I'm going to be mounting the body. So we've gotten into the era of mounting the body using magnets. And so what I wanted to do was I wanted to incorporate the magnets into the frame, right? I didn't want to have extra things hanging off here and there. So I incorporated the magnets inside of the frame. What I did was I designed it to be inside of the servo bracket. So this whole bracket comes off, right? And it's just for the servo portion. I sectioned this off so that we can have uh, upgrades, and you'd be able to just take parts off and put new parts on. But as you can see here, I have them stacked. There's 5 rows of 4 um, inside of here, right? Or no, I said that wrong. There's 4 rows of 5. So these are stacked up 5, and there's 4 of them, and it's really solid. I think I have a magnet piece somewhere. I can give you an example of how strong this thing is. But this was kind of cool to design because I didn't want to go crazy and spend a lot of money on big magnets, and I already had these on hand. And that's the thing about like being a creator and an inventor. When you're in that zone and you're creating, it's kind of hard to pull yourself away into, or to even have to wait on products to come in the mail. It's kind of like, man, nobody wants to have to wait on products to come in. So you kind of work with what you have. And so these were the magnets that I had on hand. So with me having those magnets on hand, I was just like, how can I build that into this chassis? And so now the top side will have like 4 rows of two, and we'll stack it up, and then it will clip in, and it'll snap onto this right here. It'll just snap right into place like that. And this is gonna hold the body onto the chassis. It's very sleek. And it's like almost invisible. If you don't know that it's there, you won't notice that it's there. And so that's kind of cool. Something that I was really put a lot of thought into doing and making sure that it was something worth doing. But I thought about maybe the magnets wouldn't be strong enough to hold it down, but we'll have to see as I start to really get active on the street with it. We'll start to see how durable this is and how strong it is. And if it is, not as strong as it need to be, then we'll always be able to upgrade those magnets. And that design will turn from a square to a circle. If we can get it to hold on to that case though, we'll be good to go. This whole project started with the bare minimum of things, the cheapest that I can buy things. So a lot of the servos, I, like in the beginning, I just wanted to see if I could design it and it would actually work. You know, I wanted to see if it would actually work and be something. Uh, it would be functional. I wanted it to be functional, and because I didn't want to put the money in, you know, great parts, overly expensive parts, just so I can go ahead and do something crazy and have those parts burn out on me and be out of luck. So I went with the low cost route, bought the ones that I can do some testing with, and then eventually this thing is gonna hop around. Eventually this thing is gonna hop around and it's gonna do some craziness. Um, what you got? Oh, cool. You got it together back there, huh? Another fun part of this build was the wheels. So when I first set out to design a lowrider, you just have to have Dayton's, right? For lowriders, you gotta have Dayton's. And I was playing around with the idea of smaller wheels and how small the wheels look on like a realistic scale lowrider. And for us with the 110 scale, the differential is kind of around the same size as the wheels would be in reference to a realistic scale um, tire. So when I originally printed the first wheels, they were so small that they were around the same diameter as a differential. So there was no normal drive height. Like I had to have the thing fully extended to the top in order to get it to drive, and then I had some scraping going on at the bottom. So what I did was I went ahead and redesigned the wheels, and I added a little more beefiness to them. Uh, give it that it's got that 50 spoke look. It's not necessarily 50 spokes, but I did what I needed to do to make it strong enough to for impact. And then I wanted it to print in a way that the plastic wouldn't want to pull apart. So how I got around that was I just doubled up the layers. Instead of having it to print um, um, like a as in an infill, I went ahead and I had it to print as a wall. So all of these like I could actually give you an example. Like I designed this thing to come apart the way I would want something to come apart. And this is actually function it functions just like a real knockoff. Like if you had a real lowrider, it would function that same way. It'd come off and so this here, if you could see how the spokes look, and they are actual spokes. Um, but I had it printed to where uh, the layers or the walls went the full extent of the spoke, and not necessarily just peppering it together in the circular manner. And what this creates like kind of like a real string. So it's like a bunch of strings that are creating these spokes rather than it just being a solid infill. And I did it this way because I kind of wanted it to have a little give, but I didn't want it to be so rigid that it would break on impact.
Yeah.
So that was something that I put into the design. Yeah, it's a melted ice. Hmm. Yeah, it's just melted ice now. You gotta love kids, right? But yeah, when I thought about that design, and I had a that's the thing about creating. When you have say you find something on Thinkiverse or whatever that somebody's already done, um, and the design is good, uh, most times it's not created 100% for what you're trying to do exactly for your projects. And so sometimes you'll run into some problems. Sometimes the scale will be slightly off, or you'll need to adjust and do some adjustments. Like this wheel, like the original wheel that I had, I couldn't scale the wheel up in size because then I would have lost the dimensions on the hex in the middle for this here. So I just had to go and redesign one that's specifically meant for this chassis and how this chassis sits. So when I came together with the design, that was it. I got the first print out. Um, I threw it on, and I was actually shocked it worked like right away. It just like it came together. It was the right height. The bottom of the linkage wasn't scraping the ground anymore, and uh that was kind of like a win after win for me, just to be designing this thing and just to be able to touch every single part and put a lot of thought into how I want these parts to function together and how they are in relations. Uh-oh, I just broke that one. I gave it a little too much. But now I gotta think about how I'm gonna structure that to where that doesn't happen. But you'll run into things like that as you do design. You'll start to see that how you're printing, like how these parts are printed, um, how the machine is laying down those layers is gonna make a difference in the structure and the strength of that part. Um, and so it's always a challenge to find the best angle to print things, um, and save, as much filament as you can, and how to bring all of that together. So- But yeah, so like I said, this has been an ongoing thing. Um, but it's been a dream to do it. It's been very fun. I've been at this for a few months now, designing this, and
I really haven't had any input on it. It's been coming from my own mind, and um, now that I kind of have it, I have a visual structure and a visual base um, to work from. Now I'm reaching out to the community because they can kind of see, you all can kind of see where I'm at with this build now, and based on what I'm trying to accomplish, some of you are experts and could actually, figure out the geometry of some of the things that I want to do here. Um, One of the cooler things was choice of batteries, right? So remember I was just saying about when you're getting your working zone, you're just working with the parts that are around the house, and you're just, you're doing what you can with what you have. Well, I had some 18 650 batteries, rechargeable batteries laying around, and I was thinking how cool it was to use these for RC, and to be able to charge them individually rather than have a battery pack that's gonna go dead, or a cell that's gonna get jacked up along the way, and you'll eventually have to replace them. But this brings longevity to a battery pack because I have these wired in series, and I can take each in it. I can take every individual battery out, and I can put it into my charger over here. Like I have four going already on this charger here. So I have this charger for this, that's designed to maintain these at a certain voltage at all times, right? And so with this being something I had on hand, I thought, why not use these, for this project? And so I tried them out, and they worked, and I've been rocking them ever since. And they have such a high such a high mAh that the charge on these lasts a really nice time. This is a 5,000 mAh batteries. So having these in series like really cranks out how long I can mess around with this thing. And given that I'm working four servos at the same time, that just makes it a lot more crazy to think about the type of battery power that you would need to have in order for this to function, and for you to play with it long enough to get bored after a while. Because she is.
Yes, babe.
Yeah.
The video. Stop. Baby,
And we are just under halfway done with this print. We're probably only about 30, about one third of the way in to this print.
can you zoom it in?
No, this is live. Hey, 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 hey! Look, can you throw that away, Drew? Throw that away for me, please. That cup. Throw it away. Thank you. I think we're far behind on this on this stream too.
No one? Yeah.
So I put the wrong screws in. I have two different style heads. I have the screws for inset holes, and then I have the ones for the pan head. And they just happen to be two different size hole hex holes, which is kind of inconvenient, but you work with what you got, right? So I designed this so that every major part breaks away from another. So you're not stuck with just one chassis and all of these chassis. The whole chassis is designed to where one part fits on top of another part, and then in order to get to one part, you have to remove some like a bunch of other stuff. I didn't want to go through that with this chassis, so I designed it in series, where the front suspension separates from the servos, and also it separates from the actual chassis. And we did it because we did it that way. We have the ability to upgrade different parts. Like say I find an issue with one of the parts or how it's designed, I could always just upgrade that rather than having to upgrade the whole chassis and reprint that, because that would just be time consuming and I'd waste a lot of filament designing that way. But so the idea is to just design in small increments and then have points that they bolt together. See, a hex hit, just like I was saying before. And that little hex. But I'm gonna put this back together so you all can get like an example of the front suspension and what we're doing here. You all have any questions or any ideas you want to talk about? Feel free. This is an open dialogue environment. Give you a little preview of what's going on here. So the whole goal with this build is it evolved around having enough switches to operate everything I wanted to operate at one time, at any one given time, which was having the four servos functioning one at a time with their own switch. And I went with the Fly Sky transmitter for this project because it already had those together. It's a budget controller, and you can do a lot with it. It's very programmable, and you can flash and do all kind of things with it. Um, so when I first got it, I was I was limited to the 6 channel phase, where there was only 6 channels, which is fine to have 6 channels, um, and to be able to control each wheel. But I also wanted to um, I wanted to be able to control the front end and the back end separately as well. And I couldn't really do that with the stock programming in this transmitter. Um, because it only comes with 3 mixed channels. So in order for me to get more mixed channels, I had to flash this thing out. And so I went with Open TX, and I flashed this thing out, and it's been working wonders since. But let me give you an example of what the front suspension does. So out of the gate, this is at ride height, right? Now it's at full bottom. Before, what I was saying, how when this thing was low, like this at its lowest point, that it was like the wheels were off of the ground, and that was due to the wheel being so small. But when I redesigned those wheels, I took it off of the ground by a couple centimeters, so it could still roll at this level here. Um, like if there's like I'm on a concrete surface or like a tile floor or something, I can actually drive this thing at its lowest point, and it will look really smooth and low. But when I'm out in the parking lot, I have to lift this thing up, and it has to be in. This is the medium setting. You know, this is at its medium point. Here, let's go this way. This is at its medium point, right? And what you can see, it's about an inch off of the ground at this point, about an inch, maybe a little less than an inch. But when it's at its full ride height, like all the way up, you got about a good almost 2 inches of travel in this thing. So that's just to give you all an example of what's going on underneath here, um, with that front suspension. Now, the fix, or what I was trying to accomplish with fixing this thing, was the idea of these linkages not being maxed out when I have it fully extended or fully down. In order to create that and accommodate for that, I needed to lower the servo down in order to get this to sit at a nice angle, and there would be no bump steering. So that's what I had to do. That's why I'm printing this part out that you guys see printing out right now, because I had to accommodate for that. With it being so high up, you can start to see um, like a inner towing happening with the wheels, especially when this thing doesn't move how it should move. And so to get this thing to sit right and not fight with the drive chain and the diff box, we needed to redo that. But that's it. Oh snap! See, I didn't mean to do that. That's another thing I had to uh add into my programming here with my remote, is that safety switch, where when it's not ready to go, it'll have an off switch on it. Because this thing, like I said, it rips. It's a beast of its own kind. So not only do I have it on these switches here, and that's how I'm controlling this with just the switches, the three-way switch, where it's on, off, on. That off position would be the regular ride height. Um, and then the top and bottom is all the way up or all the way down. But also when I have it in the middle, I have my VR's knobs set to where I can articulate them in a slower manner, and that's full up and down for just the front half. On just this one knob, I can choose what height I want this thing to be at, and also I have it to function in the back as well. Yeah, let me bring it up a little bit. I have it to go in the back as well. So once I get the steering worked out, we'll get those STL files out to you guys so you can build your own and play around with this. See what type of things you want to create with it as well. But it really is fun to play around with.
Why do they go away? They don't want to play?
Yeah, full up, three wheel motion. You got your tilt. You want to tilt side to side, front and back, all the way up, all the way down. Three wheel motion on the left, three wheel motion on the right. Yes. There we go. So that's the functionality of it, how I have it designed right now. Um, this thing would have been a lot easier and a lot simpler to put together had I went with a two-wheel drive, but who wants just a two-wheel drive, you know? We want cool stuff around here, so four-wheel drive was the only option for me for this build, and it had to be done right, you know. It had to be done right. It has to be able to steer and not just look good while it's sitting and jumping and dancing, but it's got to look good when it's driving as well. And so you all seeing it firsthand, you know. Happen here. The audio. I keep forgetting to open the audio. So as I was playing around with this thing, I got a split in the plastic back here. So that tells me I need to go a little thicker on some of the walls here. That's what this is all about, trying to find the best tolerance for things and see how close you can get to pushing the parts to their limit, you know. Which is another reason why we have gone and changed so many of those plastic parts into aluminum parts, because I mean there's only so much durability that you can give these parts, especially with these type of servos, you know, pulling on the plastic and um, you know, having that type of torque happen rapidly. uh, it just puts a lot of strain on some of the parts. So when that happens, hey, all you can do is rebuild, right? Make it better, faster, stronger. You know, throw it on the print again and see if it holds up. We only halfway with this print.
You want me to find like you guys?
All right, I'm gonna let this rock for a little bit. Free to comment or dialogue. I'm still looking at the comments. But thanks for being here. For those that's in here checking it out, thanks for being here. Thanks for showing support and showing love. It's not often that I do share um, my creations and the things that I'm designing. Um, but it's also really nice to reach out to the community and get around like-minded individuals. Just people that's maybe designing their own car as well, or that could bring something to the RC community. But and it's always cool to see where other people would take your ideas. It's one thing to have your own ideas, but it's another when you have people around you that have different walk. Everybody come from different walks of life, and some of them are real professionals in certain aspects of design. And can give a more sound logic to designing certain parts or um, creating certain things to function a certain type of way. Like uh, somebody that's new to RCing wouldn't think much about having a trim speed on throttle. Where when you hit the throttle full throttle, um, that it doesn't just take off 100% right away. It just gradually goes up, and there's a line curve to the acceleration. But I mean, only somebody that's advanced in RC would know about that and how to get like a car to pull off slowly and then gradually get up to speed. So when you got those type of people around you, they make your builds better. They make your product better. They make you think better. They'll start to give you things and ideas that you weren't thinking about before that you have to pay attention to if you want things to be better and at the best. So I figure I take a chance at communicating with other people. I'd rather be talking to the community about these things rather than just sitting in my own head about certain designs and how I create these things to maneuver. Because I know, like the other day, when I was designing, when I was trying to redesign this servo mount, I was having such a hard time with visualizing it. Even when I was inside of Fusion 360, I still was having a hard time visualizing it coming together and how everything is gonna sit. Um, and so I eventually had to just talk myself into just going with a design. Just do something. Like I know sometimes it's easy to, like, if you're trying to give advice, you can give advice, and advice is really really good, right? But sometimes when it comes to yourself, it's like you don't have that advice to give to yourself. So uh, when you have somebody and you're able to look at it, you're able to see it from their perspective and their idea of how it should come together. It draws a comparison to where your mind is, and then it helps you to kind of make a decision on a design or how you feel how you feel about designing a part. Because sometimes I would design a part, I'll print it out, I'll put it on, and like literally, like it'll feel good when I first put it on. I'll be like, all right, I'm done. I'll put it down, and I'll come back a couple hours later and I'll look at it again, and I'll have a whole nother idea of a better way that I could have done it. and I will act on it. Even I'll go back to the drawing board and I'll try to recreate that part again. Like when I first set out to create the front suspension, I designed this thing. Um, the bracket for these servo mounts, I went through maybe 8 iterations of the design of that. So it took me about 8 times to get it to where it's just a two-part bracket now, where I can pull the servos away from the actual chassis without taking the whole chassis apart. You know, but yeah, so it took about 8 iterations, no joke, and that just all happened within my own headspace. I wasn't communicating with anybody else about how I was designing this, and I wasn't getting any feedback in real time either on what the progress was and the things that I wanted to accomplish with it. Because I know I wanted it to be accessible, right? Like when we're designing, like a lot of the RC cars that you get from the store, they come with a whole base, and everything is kind of crammed into that base. No parts of the chassis could really be removed or replaced. Rather, if you break a part of the chassis, in most cases, you have to replace the chassis. And so, designing this was about making it into portions where there is a servo mount, there is a mount for the differential, there's a mount for the differential mount to the chassis. You know what I'm saying? And then there's a mount that holds the drive chain and all of that stuff. Like I wanted to section it off to where if you wanted to go crazy and redesign whatever you saw that you could do better, that all you had to do is just focus on that part and that part of the mount rather than try to redesign the whole chassis. And so it has been coming together. It has been coming together. Like for instance, a good idea, and I'm glad I did it this way, was um I mounted the battery tray in the back. But the way I designed this tray is that the tray just comes out. Now, if I want to do like a smaller set of batteries, I can always redesign what's happening here. I can have like a 2 channels of batteries sitting here down the middle. I can redesign this tray, and I don't have to worry about messing around with the rest of the chassis to do it. All I have to do is take some measurements for the new batteries or whatever and draw it up and print that thing out the way it is. But it just leaves so much room for innovation. Um, and that's what we want. Like that's what I want. I can't speak for everybody, but um, as I didn't design this whole thing at the same time. I designed like one part at a time. Like I started out with the chassis, and then I added parts to it from here. From the middle, I worked out from the drive shaft. The drive chain was the first thing that I designed. The gearbox. I had I started out with a design from GCZ. There's a group called GCZ, and they design like their own chassis, 4-wheel drive chassis, and then I was inspired by that even. So when I first started thinking about my design, I had their design in mind. So I started out printing all their parts and building their chassis, right? So I built their chassis. I loved it. I played with it. Um, and then when it came to thinking about how they designed it and um, why they designed certain parts the way they did, it kind of helped me uh, to design what I wanted to do. Because what I'm doing is totally different than what they did, but the basis of how they pulled off what they did was inspirational. So when I designed what I designed, I had what they had in mind. I started out with their gearbox, which was all plastic gearing, and it had some bearings holding the gears together. But it wasn't. It was such a loud uh, operation when you were driving the car, you could actually hear all the gears churning and stuff like that. And I wanted to at the same time I wanted to shrink down I wanted to shrink down the drive chain to open up for an opportunity to have an in cab interior, because that would have been cool um to have an in cab and have the windows open on the body, to where you can actually see interior inside the vehicle. That would have been nice. But as far as keeping the power and keeping the four-wheel drive structure that I had already in mind and how I wanted to mount the servos, like that took a back seat. So when I end up redesigning the drive box and all that and the drivetrain, I decided to go with that belt. Like going with the a drive belt was. Sorry about that, you all. For those that know about kids and how kids do, my apology. If that was a bit loud. But like I was saying, when I designed this, I wanted to keep that power and not lose it in the gearing. So I went with just a drive belt with two ratios of the gears, and the least friction. You know what I'm saying? And but what that did was it added a lot of height to the drive mechanism. So now it's sitting up high. It's sitting up higher than it should be. But what I'm getting out of it is that this whole drive system is balanced. And it's balanced in such a way that I'm in the center of the vehicle. Um, the motor is in the center of the vehicle in both directions, up horizontally and vertically. Um, so that gives me a great opportunity to spin this thing and drive it how I want to drive it and drift it, and it's going to maintain its balance pretty well. Um, Everything is pretty high on the chassis, but it's not so high that it would roll. So that's another thing. Also designed the battery to sit lower in the back, rather than being up in the sides of the vehicle where we can get that roll if we hit the corners too hard. But also I wanted it for when I get ready to upgrade the servos for hopping. I wanted to be able to have that weight in the back. So having a battery back here was, like I said, was one of the craziest ideas I can come up with that was easy and effective. Um, that has proven to be well designed for now. Until somebody that's a extreme expert on the matter comes in and tells me how to make it even better than what I did. I don't have a problem with those type of dialogues. So here we are, and that thing is printing out. Sometimes that machine puts me to sleep. It puts me in such a calm mood to hear like the white noise of that just churning like that. Um, Kind of gives you that feeling of rain, like when you're sitting on the couch and you can hear the rain outside, and it just puts you in that cozy mode. That's kind of what I'm getting, from listening to this machine. Um, but it also makes it worthwhile to wait, and when you got a part printing and you're listening to it, helps you to be patient. Can't wait to get this thing together though. So that breakage that I had on this rear axle, it's due to the orientation of the printing. So maybe if I go a little more solid with where I chamfered some of those edges, if I just make them solid and not worry about the defined details, and um, I can make that a stronger part that won't snap. See, we might be able to fix that with some glue for now until we get into a place where we really, really need it to be 100% together. Designers in the chat right now? We got any designers in here? Or anybody that's doing their own 3D printing? Also, don't forget to like the screen. I know it's sometimes it can be a bit overkill to ask for a like, but sometimes it's necessary in order to grow the platform and to grow the community. So please like the stream so that the algorithm can push this out to others. I think I want the ESC to be underneath. Tape down in there. Then I designed this mount here just for a time. I think I want it to be tucked underneath on that side to get it closer to the center. It doesn't have to be totally center, but I do need it to be I need it to be in a position where it's going to contribute to the balance of this vehicle and not be heavy on one side more so than the other. But we'll get it tucked under there real nice. And also for the smoothness of the chassis too, or the smoothness of the body um, attaching to the chassis. With it having when I temporarily mounted it off to the side there, I have to kind of like shimmy the body to get the body onto the chassis because it sticks out so far on that side. But it was a temporary fix that I had to do in order to run tests with it. And it was a cool print. This thing was pretty cool. When I first made it, it was logical to have it the way that I had it. And then I had it mounted underneath the drive chain. But when I decided to move the servos here, I had to sacrifice that space. So that's not a bad it's not a bad thing, a bad sacrifice, considering that now the bed sits down in there really nice now, and so having that is it makes it worthwhile. You know, it makes finding other places to put these parts worthwhile, because it can these parts they can fit anywhere you want them to fit, and they don't necessarily have a stationary place that they need to go. You know, like this ESC is it's waterproof, so it can be low or high. It doesn't matter where I put this thing. And it's fan driven, which kind of makes it bulkier than it would normally be if it was just a regular, ESC. But it's it works, it gets the job done. And for, all the ripping that this thing does, it really does need that cooling, you know. Like this thing just takes off, and I really need to regulate that speed so that when I'm full throttle, it doesn't just take off right away. It just gradually climbs to that max speed. I think this vehicle might actually be uh it might actually drive upwards of 40 miles per hour. Like this might be a 40, 50 mile driver. Um but we'll see. I have not tested the speed yet. I just know how fast it is out of the gate is crazy. Like the thing just takes off. And it's got a lot of weight in it already. So I can just about imagine if it didn't have the hydraulics, how fast the thing would be. But it's kind of crazy to think about, especially in the sense that when you're building something rather than buying it, um, and you're able to, you know, put parts in it based off of a list of things that you want, rather than having to buy it in a full package. But all of these parts were handpicked and, you know, just placed together in a random fashion, and in the hopes that they perform well together, And so that, with that being there, man, just having that in mind, it puts you in the good spirit of design, and feeling proud about, you know, what you do when you have that free time to sit down and do this stuff. Yep, the first thing was first. In order to start moving these things out of the way, out of the side, I had to figure out what was going to happen with this steering, because I had been thinking about the steering for a while. Like I didn't want to totally uh, take up the full space of of this front bay with just the steering stuff in general, without adding a part in there or adding some extra functionality. And so, I settled in on having the servo and having my receiver up there in the front. But I knew I needed to sit low enough that it would not interfere with how low the body sits on this chassis. Because that was the whole, like, after I got the design together, the biggest struggle was, okay, getting the body to sit low enough for the wheels to look like, or for the whole thing with the wheels attached to look like it's a lowrider. And sometimes you can have a chassis on there, and then the wheels could be totally bottomed out, and you would still be off of the ground on the body, and that would be to all of these high points inside of your chassis. But this stuff is bulky. And if you want the type of strength and the power, you have to sometimes you got to go with the bulkier stuff. So the idea was, how do we get the stuff to fit on an old school vehicle, where the wheelbase wasn't as wide as how these newer designs are. Because now these newer car designs have they have the wider wheelbase, and the scoop and the hoods sit a little higher than the older school cars. So having that thickness, like when you're looking at this body, the thickness of this area here, it's much thinner than these new school cars now. The modern day style cars, you have a deeper wheelbase. So creating, like, if I had like a truck and I set this down on a truck, that wheelbase would take care of itself. But having only that much space to work with in the front, that thickness there, I had to be able to fit this whole servo bracket inside of that area and still have enough space to drop the wheels inside to make this thing feel like a real lowrider. If I put the body on, you'll be able to see, like, you know with the wheels being bottomed out, it's a good amount of a space, but it's lowrider status now. But when I first did my first iterations of this design, the wheels weren't tucking in this much. They weren't tucking in that much. I still had a little space in there, like this, and that was at the bottom point of the vehicle. But just moving these parts around and seeing how they fit together better has took it from that, and it has it all the way to where it's in there, not like that now. you know and so this makes me happy that some of the meat of the tires is tucking into the inside of the wheel wells. That was the goal for this. Even the rear end, see how much the rear end tucks in there. Having this thing to sit as low as possible, and then also when it's fully extended, having it to sit up so high that people are kind of like, where is it all going? Like, how are you able to get it to sit that low, and then how are you able to get it to stand up that tall and have functional steering and functional front wheel drive? So all of these questions start popping out when you design something like this, because those are all challenges of how to design something that has so many features in one time to go together in such a tight spot. Now, if I went with a like I said, a newer modern car that had deeper, pockets for the engine bay and all that stuff, all of this stuff would have fit just fine. I could have took the easy way out and went with a Bronco, or you know, one of these later Chevy trucks, or I could have took that easy way. But there's something nostalgic about dealing with older school cars, the classic cars. But and not just dealing with them, but to have it in the RC form, it's just like there's something enriching about having older modern stuff to show your kids, because nowadays they have just these made up cars, the fast cars that are just ripping. um but we're losing the classic elegance, in some of these RCs. And so just bring it back full circle, and show my kids, like, all right, man, this is when I was in middle school, uh elementary school, lowriders was the thing. Like, I mean, there's still the thing today, but lowriders was really the thing back in the 90s. And to have a toy that functions like this, um that tells a story about, a lifestyle, um it's kind of cool to have. It's kind of cool to be able to give that to your kids. And you know taking the challenge on it, having all of the modern stuff underneath, but having the old school body that tells a story of a design that was so popular that it's around today. Um, it speaks volumes to be able to work with that, you know, or just to be able to add your touch to it. Um, it makes you feel like you're a part of something bigger, better, something greater. To having been a fan of something like that. The Monte Carlo was one of my favorite cars of all times. There was the Monte Carlo. There's of course the '64 Impala was one of my favorites. Also the 87, 86 Caprice. Um, all my favorites, But all of these cars, what they have in common is the area in the wheelbase are so thin. They left minimal space for bigger tires. So going with those Lowrider Daytons was the only ultimate decision to make. And in making that decision, we had to, if we're trying to keep it to scale, like uh to reference a real scale car and take it down to a 110 scale, when you start looking at the difference in how small those wheels are, those 50 spoke Daytons, those 13-inch Dayton tires, man, they're really small compared to the vehicles when you bring them down and you look at them on a 110 scale. And so when you do that, you start to realize, okay, like that shouldn't really work in real life, but it did. And then it's kind of cool to be able to implement that in the RC, because in the RC world, those small tires really don't work. You have to add a little bit in order to compensate for like the gearing that you're gonna come across, like the diff box. Like cars come with smaller diff boxes. Um if we're going to make a smaller diff box, it wouldn't be a 110 scale, and I wanted that beefiness of a 110 scale. So using the 110 scale gearing, um when I decided to go that route, I kind of I bit off a little more than I could chew, as far as getting a thing to sit ultimately low like a real low rider. Um and then the diff box was damn near the same diameter of the rims. So we had to bump that up. And so the way to make it work was to recreate the wheels, bring them up a tad bit. So in reference to real scale, these rims are not 13-inch rims. They're more along the line of 15 or 16-inch, maybe 17-inch. If we're comparing scales, we're comparing um what this scale is versus what real life scale is. But that's the dimension I had to go with based on the size of my differential. Now I wanted a healthier differential for the purpose of keeping that power um when this thing starts ripping. I wanted as least revolutions in the gearing as possible, to follow the suit with the belt drive that I created here. Um, and that took a little thought, to keep that there, and be able to just make it all fit. I also played around with the idea of having having the motor, uh the look of the motor being in the undercarriage. And so if I had gone that direction, then what I would be sacrificing is the actual height that I could lift this body up. Um, because I went with I think these are 70 millimeter. These are like 70 or 77 millimeter long shocks. So I would have had to go with a smaller shock, which I could still do. And I've thought about this too. I could change the direction of um of the what you call it, of the horn, the servo horns, and have them to come straight out, to sit parallel with the ground. And then as this thing goes taller, I can have it to lift out. And maybe that's how I'll design the next one. Instead of going with such meaty, um, what you call it, shocks, we'll go a little, shorter. I have here some shocks that I bought just recently for the next build. They're not, they're about the same size, the same length as the other ones, but these ones are blue. And I wanted to add in like a color scheme or color theme for the next go round. So that's gonna be the next one when that comes around. These are gonna be kind of cool to work with. Um, Also, too, if you all know about oil types to use inside of these springs, please give me a suggestion, or hook me up with a recommendation for the type of oil that I should use inside of these things. I'm curious to know what the best way, or how the thing goes. We can figure it out together. It's my first time working with these. It's a lot of the first times for me with this build. A lot of what I'm doing first time, and so I'm here to just kind of show what it's like to design from start to finish, and give you guys an idea of what's happening here. Hopefully, along the way, learn some stuff from you all too. I would like to learn some stuff from you all if you all are, you know, are well versed in the RC world and building your own, or have experience with professional parts. Lay it on me. Lay it on me. I'm ready for that part to come out already. I want to put this thing together and see what it looks like. I've been playing around with this idea for a week now, and it finally hit me to go ahead and make a video about it and put it out there in the ethers, and get some feedback on it. Sometimes I play around with ideas in my head, and I won't do anything with the ideas. It just plays there, and I'm losing progress when I'm doing this. I overthink, and I'm thinking so much, I'm just not making any progress. But going live, just it forces me to get something done, because I know people don't just want to see you do nothing, and they don't want to see you be non-productive, and they don't want to hear you talk circles and not have logic to what you're talking about. uh but it helps me to also just uh work out the ideas that I'm thinking about. Like, it's one thing to think about an idea, but it's another to be able to articulate it and put it into works, or put it into a structure like what we're doing right now. Like that whole bracket that's being printed right now came from my mind. But if I never got out of the headspace of just thinking about how I want to do it and how to make it better, then I wouldn't even be printing that part right now. It had to be, all right, focus in, on a particular design, it don't matter how good the design is, but you have to print it. You have to at least print that first design, fasten it down, test it, and see what works on it and what doesn't work on it. And that has been the best way for me to make this build happen, is because I've printed so many parts already that are just sitting in the bins and sitting in the boxes that I'm like, maybe one day, just maybe one day, I will bring those parts out and they will work for a different build. But it's like, in order to get there, I'm more of a, like, I have to have something tangible to work with. Like, I work really well with my hands. So um for me, it's like I could do the measurements all day in CAD, and I can design it in CAD and stuff like that. But mentally, I'm not able to draw a realistic reference to how big of a difference I'm making those measurements until I see a form, or I do a printout and I actually put it on and visually see how much of a difference that made. Like, for example, um having a hole that's off by zero point zero 0.05, it seems like it would be a small thing, like if you're doing like in CAD, but in real life, if you're putting together hole like screws and holes and your part is off by zero point zero 0.05, that's a significant difference, and it will show. Like, it'll be tight, like the part will be binding while you're trying to screw it in. And like those small details like that, you don't really, if you don't have a tangible part, to actually touch and feel, sometimes it's difficult to make those kind of judgments on a particular design and how snug you want something to fit or how loose you want something to fit. Um, and then that has been a learning curve too, with designing the part and taking it over to Creality and letting the machine print, and just for those measurements to be accurate and actually fit how you designed it to fit. Because sometimes you'll print something out and it will be off, and you'll be like, what happened? Like, how come it's not a tight fit, or if it's too tight of a fit, and what made that difference happen? Is it the machine? Is the Do I need to calibrate some of the settings in the machine? Did I lose did I lose my measurements to the shrinkage, or the you know from the heat of the machine, and the filament, the type of filament, did that make a difference? And so you start thinking about all of these things that you had to factor into these parts to make them fit. Like, the perfect example is with printing upright holes, right? So when you're printing a hole in the machine has to print like from the base level up and then around. um that top surface, it tends to flatten out as you get towards the top of the hole. So sometimes you're compensating for that hole, because you know that your print is going to end up with that dip in it somewhere. There's going to be a dip somewhere in there. And so you're compensating for that and you're designing around it. So sometimes your hole is going to have to be more of an oval than a hole, especially if you need it to be precise and like for the differentials to fit down the middle, because we're sandwiching those gears on the differential. So those holes are like half circle and a half circle. But what I found was just printing down with the slice down the middle. Once I get the product, the hole seems to be too smushed, right? It seems to be not a full circle. So I'm like, one way to get around that, and this is just thinking of it from an engineer's mind perspective, is just to add zero point zero 0.05 inches to in between that area. So by that we mean adding 0.025 to each side in thickness, so that we can, once we make that printout, that hole would be a real hole, and then we won't lose it to the layer height on the first layer or the second layer. Um, but that has been the learning curve, getting that learning curve is crazy. But we are or I am, I'm getting better with everything I come in here and I do. It's getting a lot better and it's a lot easier than when I first started and I didn't know the first thing about 3D printing or the first thing about the Fusion 360. Like all of this was a learning curve into itself together. I started with the Fusion 360, um, trying to figure it out, which was a lot different than AutoCAD because AutoCAD was where I started. Well, no, I actually Sketch was where I first started. There was a thing called Sketch, like back in the early 2000s. And I used to mess around with that and design like sound booths and stuff like that. And that was when I was doing the whole home studio thing. I was designing my own studio booth and trying to figure out dimensions that way. But then as we fast forward, these the amount of stuff that you have to know in order to navigate in these softwares today are crazy. Like there's so many variations of what you could do to just one line, just a linear line. There's so much you could do to it that it gets confusing over time. And then you add that with the math that you have and the geometry you have to put together to make parts articulate, and that's a whole nother thing in itself. So it's been that on top of trying to design uh, something that's really cool that people would want, like literally want. Plug in. My phone was looking like it was about to die. And we are just at that 2 hour mark. And it looks like we are rounding the corner of this. We're starting on like the last 1/3 of this print, which I thought it was gonna print out faster than this, but I didn't want to rush it either because I really do want my what you call it, my bearings to sit in those holes really nicely. You know, this hole right here in particular, I want those bearings to sit in there good, and so rushing that would make this a oval more so than a circle. And so I took that into consideration when I was doing this, when I was designing it, and choosing the direction I want to go with the printing. Like it has to work the first time, or else it defeats the purpose of me printing out something tangible to analyze. But like I say, it's been a fun process, uh, trying to figure out where to go with the steering and to make it more sound to where I actually get a good angle on those turns and the parts aren't deforming trying to hold the servo together. We will see. I gotta figure out how to get this screw out of now. I did the okey doke by over tightening. So now I think what we'll do is we'll drill holes into it. We'll drill 2 holes into it, and then we should be able to move against those holes. See. Get a little drill action while we're waiting on this part to finish. Thank you for being here. For those of you that's here and that's vibing out with me, I appreciate y'all. All right, so I cut two little holes in here. You see that, two little holes. So what we'll try to do is two little holes. We'll try throwing some screws down in there. And I don't know why I had these screws on hand, but they look like they are the perfect size for this job here. Try to put these in there and see if we can get this thing to come out. Kind of a bummer that happened. Also, it just gives you an idea too of how if you rush a part, if you're rushing printing a part, it takes away from the integrity and the strength of that part. So no matter how fast you can get your machine to print, you always have to consider, if it's not injection mode, that there's some integrity issues as far as strength. And so the best thing that you could do as far as a 3D printer is to, let it take as much time as it needs to print your parts, and not rush into, trying to get those parts to kick out as, super fast. Like you gotta, just be patient, allow them to print, allow them to do what they do. Let's see here. Make those holes a little bigger. Right, I think we got it in a good spot now. So we can start turning away at this. We probably don't even need those screws, but we'll keep them on standby just in case. Take. See if I can turn this out with a screwdriver. The integrity of this thing, it sucks because of the orientation of the printout. When you're printing cylinders horizontally, they are not as strong as far as layering goes. So you'll have that structural integrity along this part to be kind of weak. And that's where our snap happened. Our snap happened right between the layers. Like, look how smooth that layer is. Well, you guys can't really see that. This layer is very smooth where it snapped loose, as opposed to where it's supposed to be. But if I printed this on its side, that snap would have never happened because the integrity would have been much stronger going this direction. But that just gives you an example of how, engineering plays a part even in 3D printing, because you have to think about the orientation of how layers are being stacked. And it makes a huge difference on how strong a part is going to be. So I believe I got an extra one of those. I was printing them out like crazy because I knew that eventually I would need another one. I think I have one. If I don't, yeah, see, I got an extra one. See, this is a part of design. Like sometimes you just end up with extras, and you don't even know why. You don't know why you have extras until you actually need an extra, and then that's there to just give you a to be a soothing moment on a live stream like this, where we could just replace that part out and keep it pushing. But the idea is to not over tighten. I guess that would be the overall goal, is to put it to where it's secure and we are not cranking down on this thing to a such a harsh level that it's not going to be easy taking it off, and then the part is going to break like this. Now this part is actually savable. If I wanted to save this, I could reheat this and remesh this together. But at this time, it's going to go to the trash. You know, it would just be better off going to the trash rather than me messing around with it. But that was a feature too that I added in the process of designing this to work for me. Or designing the wheels to work how I wanted them to work. The previous feature didn't wheel didn't have that feature. Like those knockoffs, you had to push them in, and they had like a click, like where you have to pop them in and out, and then you have to worry about getting the nut off inside a little tiny hole, and you had to have a special tool to get down in that hole. And I'm like, man, why would we need to have all of that to happen when we could just have the knockoff to screw on like a real knockoff, you know? And so we was able to get that to do that, and it worked. It worked. Um, and it holds the wheels on exactly how it should. Anybody else ready to see this part get finished so we can assemble it? Because I am ready for it. I'm ready. I'm totally ready for it. Totally ready. Uh, mm, 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 mm. I also know this is probably bedtime for a lot of people. So I know a lot of people aren't in here. But I still appreciate you all. Ones that joined that subscribed to my channel over the week. It's been a thrill to see this channel grow. And just to see how many people are interested in being a part of what I'm doing here. Um, it makes me happy to know that I'm creating something worth looking at. Sometimes we can feel like our worth level isn't what it should be, or we don't value ourselves as much as others do. But when you actually put yourself in a position to be seen by others, um, it's really nice to know that people find value in you. People find value in how you think and how you design and things that you care about. So that's really cool. I thank you all for subscribing. I thank you all for liking my content, for getting my views up, man. Because I mean, I'm trying to go places with this, and um, hopefully, this is one thing that takes me out of the environment of going and spending time away from my children. You know, I'd rather be spending time with my with my kids. And so for every day I have to go to work and 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 be on the road away from them, is a minute lost in their lives. That could have been a moment that they could remember, or that could change their lives for the better. So my goal is to be with my kids as much as possible, and creating this gives that platform for something that I can do that that will give me that time back with my kids, that will take that edge off of constant needing to provide and go out and make the money and do all this stuff, and lose myself in such a manner that I'm not doing fun stuff like this anymore. Yeah, because this is important. I don't know about other people, and how they navigate life and go to work and stuff like that. But for me, like, work was such a priority because of, needing to take care of the kids and stuff like that, and needing to provide. Um, that I lost touch with the fun stuff, the stuff that I was fun with, like not the stuff that I do with my kids, but the actual stuff that I did when I was a kid, when I was their age, was these cars and the models and all those things, the lowrider shows and things that I used to go to, um, that I was passionate about when I was younger, you know. But because you can't literally make a career out of it, um, it's a hobby that gets kind of put in the back seat. So with me doing this, it's allowing me to open up new avenues of uh being able to put myself in a position to take my kids to see some of those cars, or show them the coolness of a lowrider or a car show. Um, Man, or just all of what's at a car show. I mean, you go to a car show to get the base, you go to the car show for the food, you go to the car show for the models, you go to the car show for the bicycles, the sound systems in the cars. I mean, there's all kinds of reasons to go to a car show, and it all starts, and it feels really nice when you have something to contribute to a show of such fashion, you know when you have something that's cool that others could look at and they say, hey, I want one of those too, or can you teach me how to build one of those? I'd like to have a few of those in my collection. When you have something, when you're creating something like that, man, that um there's such a level of happiness and joy that takes over you. And so this my goal is to get back to that feeling that I felt when I was a kid at those car shows. uh the amazing things that people did that made me wonder, how can I learn how to do that? What does it take to build something like that? I remember the first RC car I saw that was a custom build, and then this guy made it with the body was made out of cardboard, and he made I remember looking at his rims. He made his rims out of Play-Doh, and then he had push pins, like sewing push pins for the spokes, right? And then he used like a bottle tops for the outer structure of the rims. Like, he really designed this thing from scratch. And how he uh how he did his hydraulic system was air system that he did with servos, and the little like the little turkey baster things. I forget what those are called. Little syringes, the air syringes, where you can suck out liquid and stuff like that, and you like how you feed the baby medicine. He used those for the suspension, and so he was demonstrating this to me, and I think I was maybe I was 10 or 11 years old. I think maybe I was 10. But I saw this guy on the street, and that was what sparked that initial idea that, oh, I can create my own lowriders, like on that level. Because before I was just creating the model cars, and I would make the model cars hop with the regular motors, the regular DC motors, and a little 9-volt battery, and put the capacitor on there so I wouldn't blow it out. And man, I would have such good feedback with those little cars. But to see this guy walking down the street with a RC version, and his car was way bigger. He had a sound system inside of it too. Back then there was about Walkman cassettes. He had a Walkman cassette inside the inside, where the speakers were on the outside, and you could hear the music playing. Like it was an amazing thing to experience, um, as a 10-year old. And so as I look back at that, I think back at that now, I'm like, I have become this guy. I don't know his name. I don't know what he looks like. I forgot what he looks like. But I remember his car, right? I remember this RC car that he made from scratch. And to take this story full circle, that's how it's gonna be for somebody that sees this car. When they see this car, it's gonna be some kid out there that's gonna see it and go, "Wow." And then 30 some years later, he's gonna think back, and he's probably gonna say, "I don't even know this guy's name either, but I remember his car." But I mean, that'd be the goal too. I wanna create something that's memorable and that's enjoyable, and that could create moments of nostalgia for people. Man, I've talked a lot, and we still have not gotten to that point of completion on this print now. 2 hours and 30 minutes. We are 2 hours and 26 minutes in. Um, the estimated time on that was 2 hours and 30 minutes. Maybe a little over 30, maybe like 2 and 36. Um, but I don't want to mess with the view of this printout camera, because the app is finicky. And so if we go to check the time, we may lose the visual of the printout footage, and then we'll just be sitting here looking at my desktop and um listening to me talk it out some more. But at least we got a little visual of what's going on while I talk. And I can't believe this broke. But also, it gives me an idea for the next go round, and I think I need to make it thicker. I actually could, while I'm waiting on that, I could make it thicker, and we could push that and see. Let's pull it up. Let's pull up some CAD. Would y'all like to see some CAD? I mean, that's doing this thing, but let's go over and look at some CAD work. See. Boom, 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 boom. Going back to Fusion. Yeah. All right. So both of those will sit like that. Um, we're gonna go and open up. I'm working on that right now. That was another iteration of design that's gonna be coming up next, that I'm addressing, as far as taking the link part on the bottom of this, on the back of the knuckle, would be to push it out further away from the body, or not away from the body, but push it out further away from the drive shaft. And in doing that, I will have a longer response in that turn. The closer we are to the knuckle or the center of the knuckle, the faster that turn is going to be. And so, or that might actually be a better idea to make it go closer, you know. But I mean, if we put it closer, our servo won't have to travel as much. So, but let's open um the axle. Let's get through. Now, so the part that broke is this part here. That's the part that snapped loose. And I think we have that piece or it's actually on this side that snapped. So we want to beef this up. This is what I was talking about before. See how this hole is not a perfect circle? But when I print this thing on the printer, this allowance that I created here, it's a total of a 0.05 in total. But that gave me enough allowance for that machine to mess up on this curve here. And when that happens, it creates a perfect circle. Now, I'm not sure what the logic is behind it. Maybe that's something I have to fix inside the program. But this has to be thicker. This whole assembly right here has to be thicker. So what we would try to do is push this wall up and that wall out to make it a certain thickness. It's the best I can try. So let's get to it. Let's try see what we can do here. See if I select the push. Creating like a 0.5 maybe or a 0.2 to see. So it's not going to give us a 0.2, 0.5. See, that's the thing with when you're finalizing a project and you get your lines, you get all of your fillets going and stuff like that, and smoothing out all your lines. You end up with those areas that you can't really fix without needing to select more of the areas around it. So let's try to see. Man, that's a bummer that we can't get that to just that portion to push. That pushed a slight bit, but we need more than that to happen. Maybe 0.1 would have been an ideal thickness. But just didn't feel it. Could not be deleted, you know. So what has to happen? And I'm not a professional at this as of yet. So these type of challenges, they come to me often. I'm challenged by, you know, the, um, but that this surface here could be the reason why that fillet is not pushing. Could very well be the reason why. So if that's the case, then I would have to go to this face do an offset, cut the part on that offset, and then try to extrude or draw in another portion to extrude into this. But we'll see. There's quite a few things that I can try, and because of my learning curve in this software, it's hit or miss for me. Sometimes I nail it head on, and other times I'm just going in circles trying to figure it out. I shouldn't have did that. I shouldn't have pulled it that way, because when you pull it that way, sometimes the CPU takes a complaint. All right, what's happening with you all? All right, so this is what I'm gonna do. I'm gonna draw out a beefier path for myself here. But also that gives me the opportunity to make some of these other ones beefy too, because all of these are the same size. So if this broke, chances are that the integrity of this one is too weak as well, and doesn't have enough thickness to, to take on the support of these servos. So since that had happened, let's go here with it. This is the other one. That's the front. We're dealing with the rear right now. That body. Let's make that one invisible. This is the inside, and see how solid that is on the inside. There's nothing there that we would hinder by making it, thicker. It's just a matter of the design that I chose to go with. So if I want to make this bigger, I could, and it wouldn't be such a problem. So what we're gonna do is, let's go here. Let's start us a drawing, and this is probably gonna be the best way that I know how to make this do its thing or whatever. So let's draw that circle. Or hold on, let's do this. Because I can feel like some problems happening with as far as this viewpoint. So I'll select this wall. Let's do a cut of that. We're gonna cut the body. And we only need to do one of these. Once we do this one, we can copy paste and make it fit for all the other three sides. And then we can do it again when it comes to that top portion. And then we could select our cutting face right there. And what I want to do with that is just get rid of this viewpoint here. Like that part right there. Just get rid of it. Get it out of the way for now. Then I can come in here and I can look at this and go back into that drawing. And it'll sit flat for me to be able to draw it. Oh. Let's move this drawing to after the splice. Error. I hate how these errors be happening. And we didn't even draw anything on there. All right, so let's just create a new drawing based on that angle. Okay, now we have us a flat angle to look at. Crazy. Now we're just gonna rekindle this area here, right? To project these lines here. So press the P button to project. that right there. Also that, this line, and that, and this one down here. But what I'm doing as far as projecting that onto this level is so that I can take these and just create an offset. That's all I want to do. I just want to create an offset. Offset gives me the ability to keep that shape. I know the shape is going to stay, how it needs to. So right now we were at 0.048 millimeter or inches. Oh yeah, see, judging by that surface probably was only a 0.05, which is way too thin for that. And so, see, when you're doing your own design, sometimes things like this happen, and you don't catch it, and that's okay if you don't catch it right away, because you can always go back and fix it. We want this to be at least the thickness of 1, so we want twice that amount. And while it looked good, it looked very good. We can go in, take this up to double that amount, right? We're just gonna double it. So we'll do just 0.1, right? Now we got this whole thing here. We can block off this corner. Off that corner. And get rid of that access at the bottom. Right? Get rid of that. So now when we push our extrude, we're just gonna push that outer structure, which is gonna give us that meat that we needed from the beginning. This area here. We're just gonna push that back. And we're not going to cut into it right away because we have that hole back there that we're still considering, but we're going to extrude that to get that idea started. And see, if we were cutting it, you could see that hole back there that we would be joining into and losing that hole. We don't want to lose that hole, but we do want to extrude back far enough to where that area is good. And we want to extrude without cutting into the inner wall as well. So usually when I'm doing my extrude, sometimes I'll keep it like that so I can look at what's happening, at these walls back here, because I know I don't want to cut into the walls all the way. But instead of doing a cut, I'll do a new body, and then I'll get these overlapping lines here. And when I get that motion, I know I'm in the right direction, because all of this stuff that doesn't matter, I can cut around. Okay, that's ultimately what we wanted to do here. What's happening? That's there that we're missing. These are all things that we're paying attention to when we're extruding and creating something different. So now that we see that, we can go ahead and we can carve out this area from the actual build, and it's not going to interfere with anything that we already have. Also, we could extrude out this portion of that circle too. We take that circle from the previous video, and we can do it extrude and chop out, go in the opposite direction. See if we can actually do that. No, we can't actually do that because this is a fillet. All right. See, how can we do this, right?
I don't know.
No, I can split body. I can try splitting body, right? And using these walls as cutting tools. Got away to inside. Oh, where's my phone? It's on the charger. Are you talking about the one you usually look at the videos on and stuff?
Yeah.
Um, so I try to utilize this wall structure here
I touch that.
and use it as a tool to cut.
Touch that to tough. Can I? Can I touch it? Touch it.
Hold on, Lele. Still alive, baby girl.
Touch that.
I don't know if this is gonna work or not. I'm just trying. Sometimes it don't work,
Let me try.
but we're trying.
Try that.
Fine.
Can I try it?
Yeah, see, it's not going to allow us to do that. It's that, Lele, it's the camera right there, okay? I'm using it as a camera, so you can't use it. About ready to go to sleep, huh?
No.
Well, what's up with you?
Yeah.
Pick you up. I'm live right now, Lele. Trying to peel me away from it because you're tired. All right. So I'm going to figure out how to do this because I'm drawing a blank on it. That whole part is easy. That part is super easy and can be done. Yeah. No time. Question is this right here. Chopping that portion out. Or maybe I can project these lines here onto that drawing and then carve that way. So let's get this right here drawn on top of this, right? We can project again with P. These lines here get projected. Will be chopped in now. And this side here still can be chopped. So we have to create a box around this area here. We have a print finish. This completes this. It is done. Yep. Go to there. So finish that up. So see, we got this area here that we can extrude now. Try to chop this profile here. We just want to cut area out, then it's that body frame. Let's look. But we just want to chop out enough to where it's not eating into the inside. That design is not eating down into the inside of that circle. Then we want to make that disappear so it's not visible when we do cut. We go back to that visual, we shouldn't be able to see those lines inside. So we have that. Also, this little structure right there, we can push that down and out of the way. This is just one way that I've learned to deal with some of these things on my own. I'm pretty sure there are some professional ways that people are getting to the magic without doing what I just did. Sometimes when you're not thinking about when you push that feel here, feel it could cause smoothing that you need to, where that doesn't interfere with the edges. Well, get it, and it looks good right there. Good. It's not trimmed out on the sides or anything. Smooth transition, and that's what we want. Sometimes I could think my way through these problems fairly easy, and then there are times where I try to put my best foot forward and I still end up with a blank, and which I'm fine with turning blanks sometimes, but times you want that design to be what it needs to be. Sometimes you can't get it, sometimes it's just not going to allow you to be great. And now for that hole, we go back to that sketch that we created, which I think was this. Go and pull that all the way down. That out just for this body here. Thing is, if we got both of these on, it's going to chop that first one, get invisible, so our chop doesn't show. But I do also want to be looking to make sure that chop is not going to show up on the outside of that body. You can go down pretty far before we hit that bottom surface. And keep in mind that bottom surface is already going to be there for this, so it doesn't necessarily need to be here on this part. Don't want it to cut through the side. If we go too high, it'll cut through the side of this wall here, and that'll look sloppy. We don't want that. Just want that bare minimum of a chop. So we make that invisible again. We make our cut. See, that's how you know I got too much memory going on this picture, because it's doing this now. The start taking forever to load those cuts and stuff. That means you gotta do some planning. See, now we got that hole is good. Uh-huh. You hungry? All right. So now that we have that, okay, baby girl, hold on just a second. We can take away our sketches. We don't need those. But now we can just flip, right? We can go ahead and flip this side to that side to match that. And then likewise at the bottom. So now that we got that, we can do select it and go to mirror. We got that selected. We're going to select our plane. That's going to be this side here. We hit that. And now we have both of them. That side complete. Ready to go. Ready to go. Now we'll do the same thing again, selecting both of those. And we'll just switch the mirror plane, the mirror for the bottom sides. Good thing we already had the tolerance set, because now we don't have to worry about adding tolerance in here, because it's already set. And so now if we look at our bottom portion, we can see that it all pulls together and the structure is right. Now, see, we don't want to join any of these parts. We're just looking at them. So we're going to do like this, and we're just going to create new bodies for both of them. Okay. And this gives us the ability to renege on some things if we see some things out of line. If we would have, added them in together right away, we wouldn't be able to. We would have to do a lot more work if we needed to fix something. But the idea is just to do that and then make sure it all looks right without the highlights. It looks different with the highlights. All right, so we are where we are right now. I'm going to go ahead and turn them all off so I can get the ones that I exactly want to work with right away, like those two there. So see, like what we have here, the bottom holes are different than the top holes, and we know that, we knew that, and that's why we didn't make this thing solid all the way yet, but we still got a little bit to cut out from that hole. So if we look at this thing from the top view, yes, smells good. Nice. Should smell good. All right, so we'll go ahead and fill this now. We see what's different here, and that's something that you want to kind of catch, because we are trying to have this to be part of the of that body. So what we're gonna do is this structure here that was flat, we probably will just cut that out, right? So this shape here, I could take that on both sides and we can extrude. We can extrude out, cut them into. We cut them out into the hole, or we can join them. And I think I'll probably just rather cut them out. We can do a cutout and see what it looks like. Oh, it has to look neat. If it doesn't look neat, then that's what the problem. Okay. Let's cut out and see what happens. See how ugly it looks. And we see how ugly it looks. And if it's too ugly, we just could take it back and we could do like that. But if it pans out for us, then it pans out for us. Hey, that's not too bad. That's not too bad at all. Put it to the bottom side. All right, now we got that. I mean, this is workable now, so I can go ahead and secure this in. That hole is gonna get cut out regardless, um, which is at a float right now. It's floating. If we get rid of that top one, you can see where that difference happened. So that whole hole right there is chopped out. Okay. All right. So we bring them back. We'll select those three, just those three. Then we'll join them together. So they're together now. Go into the inside of those two areas. There. Extrude those. Cut them all the way out. Now we have holes. Now this area around here, we're just gonna finesse this until we get a nice rounded area here. And we're not gonna fixate too much on how pretty this is gonna look, because it's going to take care of itself. But I mean, I would go in and curve those edges there to make that thing round. Because the overall goal is this line here may be in the way of the bolt that goes down and needs to sit on top of this circle here. But if that is a case, one thing that could be done about it is that we could cut another circle around these areas, right? We could do that. That could be an option. But the overall idea is just to make it smooth, right? So if the overall idea is to make it smooth, also we could do a fillet on these lines here. With a fillet there. So if we deselect, go to our fillet, try to make that portion smoother by going the fillet route. And if it will allow us to, sometimes it won't allow us to get that far ahead of ourselves. But see how we rounded that out? That kind of looks good to me. It kind of looks reasonable. Once you get that first fillet, set and, structured, you can push the wall back and all the rest of this will fall into place. But that is a ideal for what we're trying to do. Um, but if we wanted to be meticulous and make it even more neat, looking at cutting back, like where this circle started at, we would, continue that circle around and then smooth it out. So this angle here, the square, is not what the fillet is. When you have those squared angles, they make weird fillets. So to keep this design from being, to have too many of those triangular points like on the mesh, you try to round these things out so they end up as quadrant shapes. But I mean, there's so many options and there's so many ways to go about this. Like I was saying before, the other option would be to extrude that rather than cut that out. We could have extruded it up to this point here and rounded those edges out and just use a longer screw. But then that would add this gap in between here where this fillet is. Idea is to not use so many fillets that they're stacking on top of each other and not making smooth transitions. But depending on which areas you decide to fillet will take a different effect. Sometimes they won't let you do a fillet. See if your processor is not fast enough to process what that fillet is doing in real time, you'll end up overextending what it would allow you to do as far as a fillet. And then when that happens, you end up crashing the computer or something like that, or the software. So that first way, this line here was the first real push. Let's do this. Let's push this. Got a little circle there. Let's make sure that we didn't change any. Doing that. Okay, Lele, I got you. See if we push this, what that will look like. It's just, that's an awkward shape there that's not beneficial to be there. It doesn't have any structural value. It's just there and it's living there, free of rent. But what we could do is maybe we can pull out this angle in this corner here. So we get that right to where that is there. Now we have something workable here. See, we have something workable here. Now the idea is to get this, we have to duplicate it to the other side because we already went ahead and sliced it down the middle. So now we can do a fillet along this area here. It's back far enough to where we have room for that screw head right here, and we can do the fillet and it shouldn't be a problem. So let's throw that final fillet in here. Hopefully this geometry over here isn't gonna bother us too much. 0.5 or 0.2, 0.02. How the top fill it in. The whole thing with this is pushing these areas around to make them neat can be a bit challenging. And like I said, it's just part of my learning curve because I wasn't trained on this platform. Um, this is all self-taught. So when I'm feeling around for what I need, to make lines work, um, don't take it to heart that that's the right way to do it, because I'm just trying to figure out the best way to make it happen, not necessarily be a coach to anybody on this is the way to do it. But man, maybe some of you could give me some pointers on what's going on here. And yes, the this chassis will fit the 64 Impala. I haven't been monitoring the chat, but yes, it will. And one reason why it will fit that chassis is because um when I designed this portion, can y'all see this? When I designed the front and rear axle mounting points, I made it to where you can adjust the wheelbase to any size you want. This whole bottom side linkage that I have on the rear side um is set to where those linkages could be adjusted just by screwing, and you can play it with as much as an inch up or inch back. So you get a free play of a lot of room to work with if you're gonna build this. Now, I haven't released these files yet because I wanted to get a solid build together first. But once I do, um, just know that it'll be there. It'll be available for free because I do want to give back to the community and see what you guys could do with this stuff. See how far you take it. I mean, my mind frame and how I think of designing could be one way, but man, when I get around other people that are creators, man, my brain just melts. So I'm interested in seeing like what other people would do with this design. And when I was doing the reason why I'm on this right here is because when I was doing my uh I was doing a preview of what the suspension was doing, like the hydraulics, and it's in the beginning of the video. If you go back, you'll be able to see it. But the actual axle part, where the shock mounts to the axle, that a hole broke. So that pointed out that my hole thickness was a little too shallow for the amount of force that those servos is putting on the suspension. So then I came back in here and I think we added a 0.1 inch thickness to this wall. So that should be plenty to make it sturdy and, carry out that thickness that we need so it won't break again. Or not this hole over here, but the bigger one. And it was a little too thin for what we was doing. So we found out today, and good that I found out this way, showing you all rather than, putting the files out and people having problems with their stuff breaking and that type of stuff. We don't want to happen. But initially, what we were working on was, I can go back over to it. I was designing the servo mounts. If we go back over to the workbench, um, or Creality. I had designed that and I just printed this out and was gonna put it in. And while we was waiting on it to print, I end up I end up designing the thicker hose support. I love working with ABS. When ABS cools down, once it cools down, it's really nice and everything comes off real nice and smooth. So what we did with this, we wanted to come together and create a better, um, a more robust uh, way of handling the steering, because the steering has three different levels that you can steer this vehicle at, or there is three different levels that you could steer at. So uh, my idea is to build something where the steering doesn't change no matter what height you're on with your hydraulics, because that sucks to be fully extended and now you have the death wobble. um but going through the designs and trying to figure out how to get everything to fit just right, you know we had to figure that out overall. Let's see, we got the servo mount there, and then this side here would be the exact height of that other side over there that was going on with the servo. So these will work hand in hand. And then a place for this to go, because I'm just tired of this being on the side. So the goal was to have this to print fast, but not rush it. But it ended up taking like 2 hours of print time. So that sits in there, and this just slides right down in here. I wanted to create this and design this to be plug and play for whatever your needs are for how you want to design this thing. See, and yeah, it's got to be beefy, right? Especially like once you see how this thing rips, you'll understand that when the first mount that I had, like so much force was being put on the turn that it was causing the uh the chassis to like deform a little bit, and you can actually see the thing moving around. Now, yeah, the ultimate goal is to get it to the hopping phase. It's not in hopping phase yet. Right now, it's just in a dancing phase. Here, I can give you a quick tutorial of it. But I am excited about where this mountain sits in. Is really nice. I'm happy about that. I'm so happy about that. Oh, disconnected the battery. I'll show you a little bit of the dancing from the top view. So this is like regular drive height. That's with it fully down. But the idea, like I said, is to get no toe movement from being fully bottomed out to being fully up top. You know, a three-wheel motion from just side to side. But it's just a dancer for now. So we got the switches, and then also we got the polarity changers that moves it in a slower motion too.
But so once we get this portion here situated, which was the main goal today in this video, to get the steering together and get that situated, and then I can readjust where I want this to be. Because the what I noticed with driving is that the weight of this does play a huge part in how the steering is taking effect too. With the because it has the fan in it as well, it adds a little weight to that side. So my idea is to tuck that more under. So once I got the servo on this side, um, these two together probably weighing out about the same as the the ESC. So having the ESC on this side, but tuck it a little closer, will kind of balance it out and distribute that weight to be center. So that's where we at right now. Right now, I'm using the most generic servos that I can get from Amazon. And the reason, oh baby girl, I'm almost done, okay? Yeah, I didn't want to spend all the money um in the experimental phase and then blow some stuff out. These are the servos here that I went with. I'm not sure exactly what the brand is, but this is what they look like. And I went based off of the picture. This is a 20 kilogram. Um, I do not know what the actual brand is though. But that's what it looks like. When you see it on the picture, you'll know it. And they sell them in bundles of 4 or 6. Um, just depend on whichever you want. I went with a 6-pack because I'm trying to max out how many servos I can get this thing to be working at the same time. But yeah, the faster, higher twerk. Yeah, they are hell of expensive. Like I was looking at some and I was running the numbers, right? So for these, this is perfect. But these are only like 6-volt servos. And if I want to get to the hopping phase, I need to have it up around 8 volts, to get the thing bouncing and going crazy. But once you start going into those higher volt servos, you're also looking at the speed that the servos can actuate, right? So that speed needs to be somewhere around, like if you're moving at 60 degrees, you want it to be within 0.07 or 0.08 0.08 seconds to a cycle. So once you hit the switch and within 0.07 seconds, you hit that your servo the servo horn would have moved 60 degrees. And so that's when you're hitting the hopper phase. But when I first set out to create this, I didn't know the geometry of all of that stuff. So my idea was get the most I can get for my money, but it's still cool to be a dancer, you know what I'm saying? And especially for the first version, this is really cool for the first version.
Are you doing?
I'm talking to my peoples.
To who?
All the like-minded individuals out there that love to do this stuff.
What they name?
I don't know. We got Juke 179 179R. What's the history behind your name, if you don't mind me asking? Okay, I'm gonna get you. Yeah, the hobby can be very costly too, especially if like you don't have your own printer like I do. Because buying those parts, man, you have to know what you're buying, and that's what I noticed too. Oh yeah, the '90s though.
Hey, that was my thing back in the day too. Graffiti all day. My graffiti name was Art. It was cliche name, but it was something that everybody could remember. What you gonna eat? So let's get that full bed that we are back here. Right, bro. Thanks for stopping in, man. It's a pleasure to have been talking with you. I hope to see you in the next one too, man. I got a whole bunch of things that I'm gonna be introducing as far as that I'm doing with this vehicle. But enjoy your day, man. All right, so we have this thing printed out, and so tomorrow I'm gonna come in around. I'll probably come in around the same time. I'll just start. If you're not subscribed already and you want to see more of this build, um, make sure you subscribe, and do the bell thing so that you can get that notification when I come back in. Duty is calling with the baby girl. She's hungry, and I've been putting it off, trying to get this out of the way. Um, but I'm gonna end it here, and then we're gonna pick it up tomorrow, and we'll assemble this. I won't put this together without y'all. Um, I'll put it together so y'all can see exactly what's going on here with this, and why we did everything the way we did it. Okay, so that'll be for tomorrow. It's all the perfect height. It's where we need it to be. Man, I'm satisfied with the way this came out. But all right, y'all. Thank you for coming in here, and thanks for chilling out with me and relaxing and all that good stuff, man. It's a pleasure. As always, man, uh, your dreams, man, are the most important thing that you can hold on to from your childhood. So, don't let it be a backseat, driver in your life, man. Get that thing in the front seat with you. No matter how much time you have to put in away from home to provide for the family or to have your job or whatever, do that, but also keep in mind that happy moments in your life where your childhood was fun, and implement that in your adult life if you're an adult. And if you're a child, man, keep rocking and keep on dreaming and do things that you like to do. All right. And don't give up on it. But I love y'all. I want to see y'all in the next one. All right. Well, we're gonna cut it here.